All right, example 6. Find the critical numbers of g of theta equals the square root of 3 theta plus 2 cosine theta. All three of these examples did not use x. Okay, more often than not x is used, but just know that x doesn't have to be the variable. In each case, if you take a look, f of z, z is the independent variable. F of t, t is the independent variable. The one that's in the parentheses acts like x would act. So in this case, we have g of theta. Theta is the independent variable. Theta is like x. All right. When you see a trigonometric function and there's no interval, expect infinity answers. Because trigonometric functions are repeatable, periodic functions. They just keep on repeating themselves again and again and again. So if there's an answer, there's going to be infinity answers. Okay, so we're going to have to write infinity answers, which the answer is not infinity, there's just infinity of them. So if you start counting them 1, 2, 3, 4, and then like 55 years from now you're about in the billions or something like that, and you still have like infinity to go, you're just going to be mad at me. So anyway, I'm going to show you how to write infinity answers. There's a way of doing it without having to get writer's cramp or anything. So anyway, critical numbers of g of theta equals that. So the square root of 3 theta, be careful when you see radicals involved. This theta is not underneath that radical. Square root of 3 is the number, theta is the variable. So when I do g prime of theta, considering that I've got 1, 2, and 3 over here, right? What's 3 going to be?
3 is the 1 half. Or no.
Oh, right here, number 3. Empty set because there is no interval. Right? If there's no interval, then there's no number 3. And as soon as there's no interval, number 3 is right out. If there is an interval, put the endpoints of the interval as 3. From theta equals 0 to pi, 3. Theta equals 0 and pi. All right, so whatever the interval is what 3 is. All right, g prime is going to be, for this term, what? It's really, really easy.
1 half. 3.
It's easier than that.
Easier?
What would the derivative of 2 theta be?
2.
What's the derivative of 5 theta?
Oh, so square root of 3.
Square root of 3, right? Square root of 3 is a number. All right, just because you see a square root doesn't make it not a number. So square root of 3 is a number. If you have number times letter, its derivative is just a number. It doesn't matter what the number looks like. If zoo was a number and you had zoo x, its derivative would be zoo. That's all it is. Number x, derivative is just a number. So number square root of 3 times variable theta, derivative is the square root of 3. What's the derivative of 2 cosine theta?
2 sine.
Negative.
Negative 2 sine.
Negative 2 sine theta. Very good. All the cofunctions have negative derivatives. So derivative of cosine is negative sine. The 2 is just a constant multiple. It does not do anything to the derivative. It just comes along for the ride. So negative 2 sine theta. That is the first derivative. Let's focus first of all on number 2. Number 2 is all about undefined. Okay, we have the square root of 3 minus 2 times sine of theta is our derivative. When is sine of theta undefined? Never, right? You can do sine of anything. All right? It repeats itself. From 0 to 2 pi is one period of sine, right? And then it repeats itself, but it never is undefined. All right? So, as far as the number 2 here, never undefined. So finally, the only thing we have left is the equals 0 part. All right? So all we got to do is solve this trigonometric function for theta. And the way we do this is, first of all, we get sine of theta isolated. So I want this all by itself to begin with. And the way we do that first would be to move the square root of 3 over to the right. So negative 2 sine of theta is equal to negative the square root of 3. Then we simply divide both sides by negative 2. And that gets me to this point. Sine of theta equals the square root of 3 over 2. That looks like one of those special numbers we saw with sine last year, right? Where we memorized all the trig values, all the sines and cosines of all those angles, right? In calculus we use radians, not degrees. So we want the radian values where sine equals the positive square root of 3 over 2. And I want you to write them like that, vertically positioned for one another. Because again, we want to write infinity answers. I just found one of each. So I'm up to 2. I've got infinity minus 2 to go. And I'm already feeling my wrist hurting a little bit because I feel like I got to write a bunch of stuff down. Right? brain's starting to expand a little bit and it's about to blow up. Got about all these numbers. All right. Pi over 3, 2 pi over 3, that's where sine equals square root of 3 over 2. If this said sine of theta equals 0.1345, inverse sine 0.1345, make sure we're in radians, not degrees, here we are, hit equals, and it'll spit out some number. All right? With this, inverse sine of the square root of 3 over 2, where's the square root of sine? Square root of 3 over 2 comes out to 1.047197551. Square root of pi over 3. All right. So if you get one of these 1/2 square root of 2 over 2, square root of 3 over 2, 0, or 1, one of those 5 magical numbers for a sine or a cosine, please get me the exact answers off your sheet, or hopefully out of your brain. Hopefully they're still in there somewhere. You just have to access that memory. But if they're not in there, maybe you can put them back in there. You memorized them once, you can do it again. The more you use them, the better you'll get at it. But those are the exact values. I'd rather get exact values when possible. All right, pi over 3, 2 pi over 3. Now, here's what we deal with sine. Okay, there's 6 trig functions. Let's go with sine, cosine. Let's go secant and cosecant. CSC. And then we have tangent, cotangent. Okay, I'm putting those 4 together and the bottom 2 together because the top 4 have the same period. Period, how much it takes to repeat themselves. The period for the top 4 is a 2 pi period. The bottom 2 have a pi period. Okay? For the top 4, you have to find 2 answers. And what we're going to do for the top 4 is we're going to add 2 pi n, where n is an integer. And for the second answer, we add 2 pi n, where n is an integer. If this problem here says sine, cosine, secant, or cosecant, and you find your 2 answers, you're going to add this exact thing every time, because that's their period. For the bottom 2, guess what we add? Pi n, where n is now an integer, okay? But you only have to find 1 answer. Because you get answer 1, pi away is answer 2. So the 2 answers you would get between 0 and 2 pi are already taken care of. So if you find 1 answer, and then you add pi n, where this you have to get 2 answers, and you add 2 pi n. In each case where n is an integer. Okay, so that's how you write infinity answers. This answer plus every number integer multiplied by 2 pi added to that. So -1 times that gets me another one. -2 times that gets me another one. 55 times that gets me another one. 5,965,444 times that gets me another one. All right. So again, you've got all the answers there. I've written infinity answers. Didn't even get writer's cramp. I've done all my checklist. Got nothing off of these 2. Got something off of this. There's times where there's no critical numbers at all. That's fine too. If there's no critical numbers, just empty set the thing. All right. But for now, it says find critical numbers. That's your task.